Okay, kids, so 4C assignment, chapter 3, assignment for 4C, question 18. And question 18 says there's a 14 kilogram wooden table. And here's my picture of the table. Remember, all free body diagrams look like that. Mass is 15 kilograms, and we're going to say this way here is to the positive. And it requires a horizontal force of 50 newtons. There it is, force horizontal, right there, force horizontal, positive 50 newtons. So that is pushed across the floor at a constant velocity. So the velocity is constant, which means acceleration is zero. It's not speeding up, it's not slowing down, acceleration is zero. And we're going to draw in our given here a free body diagram. So the first thing we do is we draw the table. Everything looks the same, it's a box. Then there's the downward force here, which is the force of gravity, which is also known as weight. And it is equal to the mass of the object, in this case 15 kilograms, times the gravitational field strength near the surface of the Earth, which is negative 9.8 newtons per kilogram. That is also always known. Since it's on a surface like a floor, I would assume, and it's not falling through the floor, and the floor is horizontal, we know that there's a normal force supporting the table. And we know that the normal force is equal in magnitude, but opposite in direction, negative sign, to the force of gravity. So we have that force. So we have the force of gravity, normal force, that horizontal pushing force, and there's also a frictional force, and it's acting in opposition to the motion, and it's, since the object is moving, we know it's a force of kinetic friction. We also know that there's an equation for the magnitude of the force of kinetic friction, and it is equal to the coefficient of kinetic friction, mu k, multiplied by the magnitude of the normal force. It's a very special equation because there's magnitudes on each vector. That's the way it has to be. So let's get into the question. 18A. What is the normal force acting on the table? Well, that's our required for part A is the normal force. Have to do analysis. Is there any equation that'll let us know what the normal force is? Well, I think if you take a look at the free body diagram, you'll see an equation for the normal force. Oops, I just erased that. Let me fix that. There's an equation for the normal force there. It's right here, and it's negative the force of gravity. And there's also an equation for the force of gravity. So if you use these two equations right here, you should be able to figure that out. Next, the required for part B is they want us to calculate, the required for part B is they want us to calculate mu k. And the analysis is right here. Is there an equation with the coefficient of kinetic friction in it? Yes, it is. It's this equation right here. So all I've done is I've taken this green equation right here and I've rearranged it. And put it in my analysis portion of GRASS. So if I want to calculate the coefficient of kinetic friction, in the denominator there is the normal force. Do I know what the normal force is? Yes, I do. I just calculated it in part A. So that's good. Do I know what the magnitude of the force of kinetic friction is? No, I don't. But is there another equation that would have force kinetic friction in it? Yes, there is another equation, and it's probably the most important equation in this section. It's the two equations that bring Newton's second law together. One says that F net equals ma, and the other says that F net is equal to the sum of all forces. These equations should always be used together, always, okay? So what do we know here? Well, we know the normal force and the force of gravity cancel out. So we have F net is equal to the horizontal force plus the force of kinetic friction. And remember, this force of kinetic friction is what we want to solve for because we eventually want to plug it into there, into the numerator part of our solution for coefficient of kinetic friction, mu k. Well, I know what this is. It's 50, right? Do I know what the net force is? Because if I know what the net force is and I know what this is, that's my only unknown and I can calculate it. Well, if you're smart, you do. Look, acceleration is equal to 0. So look, kids, if acceleration is equal to 0, I don't care. 15 times 0 is 0. F net is 0 newtons. So now all of a sudden I know this. I know this is 50. I can then calculate the force of kinetic friction, plug it in here. I knew the normal force from part A, and lo and behold, I can then substitute and then come up with a solution. Oopsie, a solution, that's a better S, for mu k. So that's the hint for this one. I hope you like it. Have a great day. Bye-bye.